Welcome back. Nice to see you all again. And this time we have what I called a data structures in dynamic programming week. And you'll see just in a second what this is all about. First, I wanted to share some contest stats with you. So this week I took part in 7 contests. 4 of them were rated for me, and in the remaining 3 I participated unofficially. On the positive side, I took second place in Hacker Earth's Easy Challenge, got to the first standings page of the LeetCode's bi-weekly contest, and had my best top coder performance so far, which saw a 164 rating points increase. Actually, all 3 of these are my best performances on the corresponding platforms. On the negative side, Codeforce's Halo 2022 didn't go so well. I only managed to solve A through D, but luckily for me I only got negative 15, a surprisingly forgiving rating change for such an underperformance. Also, the remaining 3 unrated contests, I didn't really take them very seriously, which I think is a bad thing, because I really was just not paying enough attention in certain problems which I should have solved. One more interesting fact is that Saturday was a very busy day for me, with a total of 4 competitions. That was a lot, and it actually got me so tired that I could not wake up at 4:30 a.m. on Sunday for LeetCode's weekly contest. And I think that 7 contests a week is as far as it gets for me if I want to upsolve a reasonable portion of all the problems I see. Next up, I want to share some problem stats. So there were a total of 44 problems. I solved 32 of them in contest and upsolved 9 more. I'm yet to solve the most difficult two from the Codeforce's Halo 2022 and one challenging problem from Top Coder. The topic I had most difficulties with this week is dynamic programming with some data structures. We'll see not one, but 2 examples of such a problem in the upsolving time-lapse. Surprisingly, I also missed several mathematical observations in a couple of problems. It is something that I thought I had covered by my high school Math Olympiad experience, but apparently progress is still possible in how quickly and naturally I arrive at such observations. With that in mind, let's jump into a super fast practice session. I think we'll start off with problem G from Codeforce's Halo 2022. It is rated 3200, but trust me, it's not that difficult at all. So, first thing we may do, and let me just rearrange things a bit over here, is transform our array into a permutation, because it's just better. Then we notice that we need to count increasing and decreasing subsequences starting and ending at each element, or rather not decreasing and increasing, but only increasing. Ones that start and end, because our idea here is essentially that in the statement, we want to compute the value of some double sum, right? We sum over all subsequences, and then over all elements we sum some indicator condition. So this sum is, of course, the order of summation can be changed, which is a classical idea. So here we want to count to how many sequences each element contributes. And the very first idea is to just count increasing sequences starting and ending at each element. And the number of subsequences containing this element will be equal to the product. As you can see, we quickly get this part working. It returns zeros for the time being, but we quickly fix that minor inconvenience. So yeah, by now we already know the number of increasing subsequences that each element belongs to. And our current goal is to account for those subsequences where an element occurs but does not contribute to weight. And you can see me working out a condition for that happening. We just realized that each element does not count towards the weight of a subsequence if and only if that subsequence ends at a very special suffix maximum. So now for each element we know that we need to count subsequences increasing starting here and ending at the corresponding suffix maximum. Now what do we do? It appears like we have like quadratic DP, right? Because we need a linear number of intervals and each interval can be computed with something similar to what we already did. But luckily for us, those, so to say, queries, those segments can be grouped by their right endpoint, which is suffix maximum, which is exactly what I do here. For some reason I counted it 2 pointers. It sort of is. We have one pointer that points to the suffix maximum, and then the other pointer loops over all left endpoints of a segment that are paired with this specific suffix maximum. You can see me working out conditions for like how to use if Fenwick tree to speed this DP up. And this is like a very common pattern. I noticed recently that you have some quadratic DP and you want to speed this up, and for this you need some sort of data structure. You can see that I still have minor, not bugs, but just incompleteness in implementation. Now I'm overcounting what I need to subtract. So as you can see, like I don't reset some values and it's hard to reset the entire Fenwick tree. But luckily for us, we can reset it in a much simpler way. So first we need to account for the last group, yes, and then we need to somehow account for those, like somehow remove our previous operations with the Fenwick tree. And it's very surprisingly simple. We can just reset all the operations that we did, we can just undo them. And it works, it just works. Well, not immediately. You can see me working out through errors. Yes, something broke, I don't know what, with int 128t. And I get wrong answer, and this is very stupid. Earlier in the video I typed the mod myself to be 998 millions, and that was the wrong model, and that we can accept it. Next up we have another problem G, this time from AddCoder beginner contest. And once again, this is a situation where you need to speed up quadratic DP. As you can see, we started with quadratic DP, we quickly tested it, it actually works, so now we just need to speed this up. And the way we do it, first we noticed that each DP value is a linear combination of the previous ones, and then we notice that coefficients in those linear combinations are suffix minimums and maximums, and this can be efficiently computed with monotonic stacks and updated accordingly. So you'll see me essentially coding up something that is reasonably close to a solution, but unfortunately after we fix boring mistakes, we essentially have what is very close to a complete solution, but unfortunately I struggle a lot with implementation here. And this is partially because in the previous problem you saw me writing things down very explicitly, potential even wasting some time on that, but I was like, it allowed me to be very confident about what I'm doing, not just trying to throw random things into the code to hope that it will work. So here I really should have just written things down, like a definition of DP, a formula for DP, pretty much anything would work. I tried to debug it in a quick way, so to say, like come up with a quick fix. Unfortunately, it doesn't work, and usually I do a lot of paperwork to write things down. But this time I didn't. It was pretty late in the evening, as you can see. It's like 9 p.m. I was reasonably bored, like tired. I don't know, bored of solving some problems that I like essentially know how to solve and just need to come up with an implementation for it. So I didn't take my time to write things down. Eventually, I will. It just needs me a longer time to understand. So yeah, in general, I think the morale of this problem is that you should really just write down definition like that, because then you immediately see what you're lacking. Well, not yet, but soon enough you understand that we'll just keep track of each sum separately, not trying to adjust the previous sum, because DPI is a bad approximation for DPI plus 1 in the sense that it blends into sums. So yeah, I realized that, and then I think I wrote down some more things. No, I just realized that the difference between DPI and DPI plus 1 is that it uses DPI in DPI plus 1, so I need to add this and I get accepted reasonably soon. So that's it. I'll clear the implementation a bit, but it won't be that different, so just like some minor renaming, some comments, and just that, I don't know. So Eternal was a simple problem, should have taken me much less time, but it's nice to get it working in the end. That's it. The last problem for today comes from the same AdCoder beginner contest, but this time it's problem H, or X, as they started to call them for some reason. Maybe they consider it to be some sort of a bonus or something, I don't know. And this is a very nice math problem where you're given a set of points in the plane and you want to find all pairs of close points. Now, originally you can say that that's impossible because the output size is quadratic, but they guarantee that output size is small. So therefore we need to come up with a solution that the running time of it should be somewhat proportionate to the size of the answer, which is unusual to see in competitive programming. Here, surprisingly, on the idea level, we want to make sure that almost every pair of points that we check works, and this can be achieved by grouping points into squares k by k, which we do, and then we just check all pairs of points in adjacent rectangles. Where surprisingly this works, if you want to find the reason why, you can see the editorial. Yeah, but the idea is just this. I think it's a very beautiful idea and you should try to prove it yourself, but here we are essentially done with this problem after seeing this idea. This is very beautiful. I encourage you to upsolve it. Well, we have some minor bugs, like we should only insert sorted pairs, but then it just works. So that's it for today. It will take some time. Yeah, but thanks everyone for tuning in. So far, I'm satisfied with how it is going. Unfortunately, next week I'll have a bit more work to do, but hopefully I will still find some time for many contests, at least on the mainstream platforms. One final thing, we'll have a live stream on January 23rd, so I hope to see you all there and drop me a comment what you would like to hear about.